I'm CJ, and welcome to the Physics Funhouse.
Hey guys, Mr. Mark with you, and CJ is going to help me demonstrate for you guys how to do the coefficient of friction lab, where we're going to try to figure out the coefficient of static friction and coefficient of kinetic friction between that block next to CJ and the table that it is on. To do that, we're going to need that force sensor that is sitting in front of CJ. You connect it to the computer just with your standard USB cable, and the first thing that you need to know is how to zero that. So to zero, first make sure that you are on the force sensor. So choose that drop down and then click on the zero button there, and your sensor is zero. CJ, if you hit record real fast, you should see that that is showing you zero force. You can just hit stop and your sensor is zero. The next thing we're going to need to know is the mass of that block plus whatever you add to it. So put the block on a scale, figure out its mass. Those things are calibrated, so you can just add that mass to the block, multiply that by g, and that'll give you the weight, which is going to be equal to the normal force. So finding the normal force on our block should be just a simple matter of adding, multiplying by g. To get the size of the friction force, we are going to need that force sensor. So the first thing that we need to do after we've zeroed it is hook that force sensor onto the string. And then we are going to pull it, slowly increasing the force until the block moves. And then once it moves, we are going to keep it moving at a constant speed. It is important that we do two things. One, that we increase the speed slowly and then pull it at a constant speed. And then two, that we keep that string horizontal. If the string is not flat, then your normal force is not going to equal the weight of the block, and you're going to have to do a bunch of trig that you didn't plan on doing. So we're going to have Mrs. It, hit the record button over there. CJ is going to gradually pull harder and harder and harder until it begins to move. He pulls at a constant speed, and it looks something like that. Beautiful. You go ahead and hit stop. So kind of zooming in a little bit. So you just slide that computer towards me a skosh. There we go. So notice that we have a steadily increasing force. And if you wanted the force to be positive, you can change the sign on the sensor. It's not terribly difficult to do that. But notice that this peak right here is when CJ first got the block to move. And so that force corresponds to the static friction force on our block. So up here, I'm going to hit the statistics button to turn on the stats. And then from the drop down, I'm going to choose the minimum. That gives me the biggest negative value, which is the static friction force on our block. The mean right now doesn't mean anything to us. In fact, it'd be better if we just turn that off. That minimum value is the static friction force's maximum value. If you have it switched to positive, then you're just looking for the positive value, which would be the maximum. So we're going to write 6.33 down for our static friction force. The kinetic friction force is going to be the average of that nice flat line where CJ was pulling it at a constant speed. So what we're going to do is we're going to ask the computer to average that line for us. So to do that, we're going to come up here and click on our highlighter tool, because I only want to select that flat region. And I'm going to narrow it down to the flattest part. So there's that little dip where the thing kind of skipped a bit. I'm just going to cut that out of there. And then instead of looking at the min, I'm just going to look at the mean. So I want the average of all those values. So in this case, that is 3.13. So I'd write that down right there for the frictional force, the kinetic frictional force. Then we're going to add some masses to our block right there. So let's grab some more masses from over there. Put it on the block. Now we're going to have a larger normal force, and we are going to repeat. So CJ, let's show them again with this one. This is it. If you'll just hit the record button when CJ is ready. Don't delete. All right, whenever you're ready. So slowly pull harder till it moves. He's pulling at a nice constant speed, and then you can stop. Go ahead and hit off. And then I didn't want to delete that because I do want to show you what the two data sets look like. So if I come up here and choose run 1, and then compare that to run 2, notice that that force got bigger there. This force got bigger here. So I switch back and forth between the two. You can see how that maximum force changed, how the average force changed, because our theory says that as we change the normal force, we should change the frictional force. So we're going to go ahead and wrap it up from the funhouse. Later on, I'll go back to the Maria cave and show you how to put this data into Excel. CJ, thank you so much for your help today. Madam Mitt ran away somewhere. We'll find her for another feature from the Physics Funhouse. Till next time.
Ta-ta.